You can see the screen.
Yes, ma'am.
Yes, ma'am.
No, ma'am.
Yes, ma'am.
Yes, ma'am. It's
Yes,
visible,
ma'am.
ma'am.
Yes,
Yes,
ma'am. It is visible.
Yes, ma'am, it is visual.
yes, ma'am.
Why the recording is not starting?
Ma'am, all recording already started.
Yeah. So in the last class, we have discussed the sufficient condition, that is RT minus S square. It should be greater than 0, and depending on R, we can decide whether the function is minimum or maximum at that point. But if RT minus S square is 0, what will be the situation? That we have not discussed in the last class. Now let me take a function. All of you, please mute yourself. Some sounds are coming from your end. All of you, please mute yourself. Now see, this is the given function. Now we will see that the nature of this function at origin. Okay, whether it is maximum at origin or minimum at origin, or origin is not at all extreme point, that we will check. Now for that we need to find out RT minus S square. Now first we will find out what is fx, xy, that is del f del x. So what will be del f del x? It will be 2x minus 2y plus 4x cube. And we know the necessary condition is to make del f del x equals to 0. Yes, please.
You are not presenting.
I'm not presenting.
Ma'am, you are presenting.
Because here it is showing, no? I'm sharing the screen.
Yes,
Ma'am,
ma'am.
it's not.
No, ma'am,
It's visible, ma'am.
Okay.
Are you recording the lecture, ma'am?
But
Yes,
ma'am, the
please.
recording is not showing.
Yes, ma'am, recording is not.
When you start the recording, there is a red at the
No,
corner.
recording
Ma'am, the
started.
recording has
See in the
already
chat
started.
section.
Recording has also started.
Yes, ma'am. No, ma'am, not
Okay,
started
ma'am.
recording. Recording is.
Chat section में देखो ना start है तो edit section नहीं दिख रहा.
Okay, please mute yourself. Let me complete this. Recording is on. I have started the recording. Some of you said, no, you can see the recording is on.
Yes, ma'am. In the chat section it's written recording started.
So it is started, I think. Okay, let us come back to the class. Now see, necessary condition was what? Del f del x should be 0, del f del y should be 0. So as per the necessary condition, we will make this one 0. What is fx 0 0?
0.
0. Now similarly, we will find out what is fy xy. It will be minus 2x plus 2y plus 4y cube. So this will also be as per necessary condition. This should be 0. And what is fy 0 0? Here actually we need not find the stationary point because it is already said that we have to check this function at origin. Okay. So at 0 0, this is 0. So next is we have to find out what is fxx, means del 2f del x2, because RT minus s square we need to find out. So what is fxx? Fxx is nothing but del x of del f del x. So del f del x we have already obtained, that is fxxy. Now on this we will apply del x. So we'll have
2 plus 12x square.
plus 12x
2
square.
ma'am.
This will get. Now what is fxx at the point 0, 0?
2.
2.
Similarly, we have to find out what is fyy, fxy. That is, we have to find out del y of del f del y. So we already have del f del y.
2.
On that, we are going to apply del y. So it will be 2 plus 12y square. So what is fyy at 0, 0? It is
2.
2. Now we need f of xy. This is also required.
Minus 2.
Now what is
Minus 2.
fxy? Del y of del x of del f del y. So it is minus 2, nothing else. So fxy at the point 0, 0 is minus 2. Now we have all the values of rt minus s squared. So therefore we now find out now fxx fyy minus f of xy square. What is the value of this? Now fxx we
0 ma'am.
and everything we are finding out at the point 0, 0. Now see fxx is 2, fyy is 2, and this is 4 minus 2 whole square. So 0. Now we have learned that if rt minus s square is greater than 0, then we'll check what is r. Now see.
Yeah, it is not maximum, not minimum.
No. When we get rt minus s square equals to 0, we cannot conclude anything. Because our conditions which we have studied till now, their rt minus s square should be greater than 0, then only we'll be able to tell something. But if it fails and if it becomes 0, we cannot conclude anything. So further investigation is required. So here we will conclude that we cannot conclude about 0, 0. So actually now we are having a doubtful case and we need to see further about this point because our test failed. But it doesn't mean that 0, 0 cannot be extrema. So we'll now check what is fxy at 0, 0. Now see, fxy can be written as x minus y whole square plus x to the power 4 plus y to the power 4. Can I write this? Can I write the function in this manner?
Yes,
Yes.
ma'am. Yes, ma'am.
And
can you initial question once?
I can write what is, please all of you mute yourself. All of you please mute yourself. Please mute yourself. Mute yourself. Mute yourself. I'm getting some sound from your side. Again you're talking.
Yourself.
Ronak.
Color Ronak.
Ronak, please mute yourself. Ma'am, just please mute.
Ma'am, now it is okay, ma'am. Now it is okay. You can.
Now see fxy minus f00. We are getting this, and what is f00? If you put the value, it is 0. So actually I can write this. So what about this? This is always greater than 0. I can say this. Whatever value you put
Yes,
for
ma'am.
x and y, you will
Yes, ma'am. Always
you will
positive.
always get positive. That does mean f of xy is always greater than the second, right? So for which is always greater than 0 for all the values of xy, I can say. Therefore, can I say that f is minimum at origin?
Yes, ma'am.
Yes, ma'am.
So when this test failed of our sufficient condition, then we have done further investigation and we arrived to a conclusion that f is minimum at origin. So if this type of thing happen, then UE need to actually see further. So let me consider another example.
Ma'am, can you show the initial question once, just once?
Why don't you write it when I'm writing? Take a copy and pen when you're doing the class and write it.
Yes, ma'am, thank you.
Now let us take another function. So this is the function. Again, we have to check this function at origin. What is the nature of this function at origin? So same like the previous sum, here also we'll find out what is fx xy. So this will be 2x minus 2y plus 3x squared plus 5x4. So what is fx at 0, 0? 0. What is fyxy? Fyxy will be minus 2x plus 2y minus 3y squared. So fy at 0, 0 will be 0. And we know at extrema fx equals to 0 and fy equals to 0. Now if we make them equal to 0, then we'll get the stationary point, but we'll not go for that because we in the problem only it is said that we have to check the nature of the function at origin. So naturally we'll now find out fxx at, first we'll find out at xy, then we'll put 0, 0. What is fxx xy? It is 2 plus 6x plus 20 x cube. So fxx at 0, 0 will be 2. Similarly, we have to find out fyy at xy. So fyy at xy will be again
2 minus 6y.
2 minus 6y.
2 by 6y.
So fyy at 0, 0 will be
2.
2. Now what is fxy?
-2.
Yes, ma'am.
Minus 2. So fxy at 0, 0 is minus 2. Now what is rt minus s square? That is
0.
fxx into
0,
fyy minus f of
Zero.
xy whole square. That is equal to 4 minus 4 equal to 0. Again, we came to a conclusion where we are unable to say anything about the function at origin because rt minus s square becomes 0. So again, here we'll see the function and we'll try to find out the nature of the function at the origin. Now, let us see that how we can do it. This function, the function can be written as f of xy. This can be written as x minus y whole square plus x to the power 5 plus x minus y into x squared plus xy plus y squared. Can I write this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Or I can write f of xy minus f(0, 0) is the same expression, that is x minus y whole square. F(0, 0) is 0, x to the power 5, x minus y, x square plus xy plus y square. Now let us put some point. Okay, let us put x equal to 2 and y equal to 1. So if we put x equal to 2 and y equal to 1, we'll have f(21) minus f(0, 0). If you put x2 and y1, what will get? In the right hand side, if you put it, 2 minus 1 whole square, 1. Here we are having 2 to the power
40.
5, 40,
32.
32.
Yes, ma'am.
40, ma'am.
40, ma'am.
So it is greater than 0. Now let us put x equal to 1 and y equal to 2. Then we'll have f(12) minus f(0, 0). If you put x equals to 1 and y equals to 2, what you'll get?
-1.
Minus 1.
Yes, ma'am. -1.
Excuse me, ma'am.
What is the value of f(12) minus f(0, 0)?
-1.
Minus 1.
Yes, ma'am.
Ma'am, do we have
Minus
to do this?
5, ma'am.
Minus 5.
Yeah.
Minus 5, minus 5.
Minus 5.
Minus 5.
Minus
So this is less than 0. Or then I'll say that f(12) is less than f(0, 0). That does mean what we are observing here. Sometimes f(0, 0) is less than some point like f(21), and sometimes we are seeing that f(0, 0) is greater than f(12). That doesn't mean it is not keeping the same sign. That we can conclude that f(0, 0) is not keeping the same sign. That doesn't mean 0, 0 cannot be any extreme point. It can neither be a maximum point, it cannot be a minimum point. That we can conclude from here.
Ma'am. Hello.
Therefore, 0, 0 cannot be a minimum. Is it clear how we came to this conclusion?
Ma'am, do
Ma'am,
we
is
need
there a
to do
way
these
to conclude?
manipulations by hit and trial method?
Yes, obviously. Once it fades, no, RT minus a square equal greater than 0, once it fades, then we need to just check, and there isn't any method actually. Whatever we are doing, this is just trial method, no? We are just seeing the function and trying to get something, as we are trying to get a conclusion out of it.
Can we use higher derivative, third order?
It will be complicated, yes, you can use, but it will be complicated. Somehow we have to come to a conclusion, that is it. There isn't any method. Okay, now if you ask me that why you have put 2 and 1, 1 and 2, why not some other thing? You can put. This is trial and error
Ma'am, is
method.
there any way to conclude that the function is increasing or decreasing at origin?
No, there isn't.
Ma'am, is it a saddle point?
Yeah, it is a saddle point.
Ma'am, if
It is a
fx
saddle
is
point.
not equal to 0 at origin, partial derivative with respect to x, then
It
can we
is 0,
conclude that
no? It
it is
is
a
it
saddle
is
point?
0. Here it is 0.
No, ma'am, in any case, it is not 0. Can we conclude that it is saddle point? Or what we will write in that case?
It should be 0, no? To be a saddle point. What was the definition of saddle point?
Okay.
Now let us come to Lagrange's method. Lagrange's method of undetermined multipliers. Now here we are considering that let u equals to f of xy be a function of two variables x and y, which is this x and y, they are connected. X, y are connected by the equation phi x equal to, sorry, xy will be there, phi xy equal to 0. That does mean if u is a function of x and y are again having some relation, which here we are saying if phi xy equals to 0, then in this case we define a new function capital F, which will equal to small f plus lambda into phi. This lambda is known as Lagrange's multiplier. So what I said, that if there is a function f of xy and this x and y, they are having a relation among them. So we construct a new function capital F equals to small f plus lambda into phi, where lambda we are saying this is nothing but Lagrange's multiplier. Now at a stationary point, of capital F, this df will be 0 as per the necessary condition. Here df is del f del x dx plus del f del y dy plus del f del z sorry, this will be lambda, not z, lambda equals to 0. Now as per necessary condition of extrema, here also we'll see that this equation will be satisfied. This equation will be satisfied if del f del x equals to 0, del f del y equals to 0, and del f del lambda equals to 0. Now the solution of these equations will give us the stationary point of capital F, as we have done in the previous cases also. Okay.
Ma'am,
Yes.
and where is d psi in df?
Where
And
is
psi is also a function of x and y.
phi?
Yes, ma'am, phi.
What?
Ma'am, pi is also a function of x and y, so there will be a d psi df by
Phi x comma y already is equal to 0, na?
Phi is a relation between x and y. That's so that's
Now see, a stationary point will be an extreme point of small f if d2 capital F or d2 small f keeps the same sign. And will be extrema depending on d2f or d2 small f is negative or positive. Actually, capital F and small f will have the same kind of nature. Okay. Now we'll come to some problems. So it will be more clear. The method will be more clear then. Only one thing I'll just let you know, that is d2f, small f, capital F, doesn't matter, can be written as ddf. And if we derive this one, df is written as actually fx dx plus fy dy. So it is dx del x plus dy del y of fx dx plus fy dy. So if you just apply this on it, you will get f of xx dx square plus 2f of xy dx dy plus fyy dy square. This we are going to apply in the problems. Now let us take one example. See, the question is, show that the greatest value, the greatest value of x cube y square and x plus y equal to k, where k is a positive constant. Okay, this is given. Is some value is given 108 k to the power 5 by 3125. This we have to show. We have to find the maximum value of x cube y square, and this x and y, they are connected with some relation, that is x plus y equals to k, where k is a positive constant. So here we will
Ma'am,
apply
how
our.
are you converting total differentiation into partial differentiation?
You please
In
read
the
some book and do it yourself. Okay, everything cannot be given in the class. How it is done, you do yourself, you'll get it.
okay, ma'am.
You'll see that when I'll upload the notes, no, their chain rule is given. In the chain rule, you can see that how it is done. It is mentioned there.
Okay, ma'am.
Now we are taking, let u equals to x cube y square and capital F is equal to x cube y square plus lambda into phi. So here phi is what? X plus y minus k. This is phi. This relation between x and y. Or we can write u plus lambda into x plus y minus k, where lambda is Lagrange's multiplier. We are converting into problem in this way. So we constructed a new function, capital F, and we are writing it in this manner. So at stationary point, what we know? At stationary point, del F del x 0. This we know. Del F del x 0, del F del y 0, del F del lambda 0. So please find out all these values. What is del F del x, what is del F del y, and what is del F del lambda. So solving, we have to get the stationary point. Del F del x can be written as fx also. What is fx? 3x square
du by dx plus
plus
lambda.
lambda. Similarly, what is fy? Fy will be 2x cube
2x
Ma'am,
y
plus y
2x
plus
square.
lambda.
Y square plus lambda.
plus
Ma'am, fx will be 3x square y square.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. 3x square y square plus lambda.
3x
yes.
square y square.
Correct. F lambda equal to x plus y minus k. And all these will be 0, no? All these will be 0 because at stationary point we know this is 0. Now please solve this and find the value of x and y. Find out what is x and what is y. So we'll get the stationary point. X and y required. Niludi!
Mom, x is 3k by 5, mom.
Niludi?
Y equals 2k by 5.
Your skin is not visible, ma'am.
Find out the values.
X is 3k by 5, mom. And y
Yes,
is
ma'am.
2k by 5.
Ma'am, please show 1 second the question, ma'am.
Y 2k by 5.
Ma'am, you are muted.
Just wait a minute.
वेट करो भाई.
Okay, what did you get?
X.
Sir, ma'am, 3 cube into 2
3k by
square by
5
5
Yeah,
to the
ma'am.
power
2k by
5 times k to the power 5.
All wrong.
Ma'am, x
3k
is
by
3k
5,
by
2k by 5.
2k by 5.
Yes, ma'am.
Yes,
Yes,
correct.
ma'am.
Yes, ma'am.
Correct.
2k by
Correct.
x cube y square करने के बाद नहीं हो
Yes,
गया.
yes, stop now. Stop. So we got the stationary point as 3k by 5 and 2k by 5. This is the stationary point. Now what is our job? RT minus a square, no?
Ma'am, lambda.
No, here we will not go
No,
for RT
ma'am.
minus a
Find the
square.
value of x cube y square.
Yeah, now we'll
Extremum
find out.
value.
Yes, extreme values we'll find. For that, what we need, first we'll find out what is fxx. What is fxx? That is del del x of del x. Will be
6xy square.
now put that point because now we'll find out at 3k by 5 and 2k by 5 what is fxx. Find out the value of this.
Seventy-two by 125 into k cube.
Okay. If yy we have to find out at the point 3k by 5 2k by 5 72 k cube by 125. Good. Now we want fyy at 3k by 5 2k by 5. Then we want fxy
If y
54k cube by 125, mom. Fy.
4 by 120.
fy is
54 by 125.
54 k cube.
54k cube by
54k cube by
125.
125.
And what about fxy?
Zero,
6x
ma'am.
square by 1 minute.
Yes.
One hundred k
108.
cube by 125, mom.
ma'am 108k cube.
125 by 125.
Yes, correct. So we
Yes,
got all
ma'am.
these values. Now see, we have a relation. Also, we know that dx plus dy will be 0 because x plus y equals to c. This is given. No, okay, k is given. X plus y equals to k. That is given. So can we write dx plus dy equals to 0?
Yes, mom.
Or
Yes.
we'll write dy equals
Yes.
to minus dx, as we know that x plus y equals to k. Now we'll apply d2f is equal to f of xx dx square plus 2f(xy) dx dy plus fyy dy square. So we have all these values. We are going to put it. fxx we obtained 72 by 125 k cube dx square. Then fxy we got 108 by 125 dx. Instead of dy, I can write minus dx because just now we have seen that dx plus dy equals to 0. So dy is minus dx. If yy we obtained 54k cube by 125 dy square. Instead of dy square, I can write minus dx square. Now see, if we simplify this, we will get
minus 90 by 125 k.
90 by 125 k cube
Minus into dx
dx
square.
square.
X square.
So, since k is a positive constant, it is given. This is less than 0.
Yes.
If d2f is less than 0, then we will say that f is maximum at the point 3k by 5 and 2k by 5. Therefore, capital F, that is u, because small, what I said, small f and capital F will have the same kind of nature. Here we have named it as u. So capital F, that is u, is maximum at 3k by 5, 2k by 5. So we obtained that this is the maximum value, and now we find out what is the maximum value of the function at this point. And the maximum value is, what is the maximum value? You have to put it in the function. What was the function?
F.
X cube by
Yes, x cube y square.
X cube by square. Yes.
X cube y square was the function. So maximum value will be x cube
108.05.
y x cube, sorry, y square 2k by 5 square. So if you just multiply, just check what you are getting.
108 by
And in
3125
the
k
case,
cube.
k to power 5, 3125.
K cube.
It matched with the problem.
Okay, power 5. Sorry.
108 by 3125 k to the 5. See what was given in the question.
Yes, ma'am, it's match.
Yes, ma'am.
Matched, no?
Yes, ma'am.
Yes, ma'am.
This is what was given to us. So that it is 108 by 3125 k to the 5. So we obtained that. So I hope you understood. Understood now?
Yes.
Yes,
yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, just let me consider another example. Find the mute yourself, all of you. See, the question is find the maximum and minimum distances of the point 4, 5 from the circle x square plus y square equals to 4. Okay, this is the question. Now here we are going to use the Lagrangian multiplier method and we'll solve it and find the distances. Now first we consider that let xy
Ma'am,
be, yes,
we can use it without we can found it without using any languages method.
yeah, I know, but here we are learning Lagrange's multiplier method. Okay, suppose it is given,
Okay,
find the
ma'am.
maximum and minimum distance of the point this using Lagrange's multiplier method. Then what you will do?
Ma'am, could you please scroll up? I'll just take a screenshot. Just for a second.
No, I cannot. From the next time, no, take a copy and pen and sit with that.
And I'm sitting with the copy.
Mother write it. When I'm writing, you also write.
Just last words.
I'm writing and I'm explaining, and you people are only listening. Then why you cannot write it? Okay, let me complete this, then I'll go up. So here what we are doing, let xy be any point on the given circle. Okay, one circle is given. Now the distance between xy and 4, 5. How we write it? The distance
X minus 4 whole square plus.
distance between xy, we have considered xy as any point on the circle. Now we want to find out the distance between xy and 4, 5. So we write as d equals to d square actually, no?
Yes,
Okay,
ma'am.
first let us write as d
Yes,
only.
ma'am.
We put the formula in this manner only. X minus 4 whole square plus y minus 5 whole. So this we have done in plus 2 only. We have done some sums like this. Or we can write it as d square equals to x minus 4 whole square plus y minus 5 whole square. No? So this is now we have to maximize or minimize subject to the condition. So we'll write which is to be maximized or minimized subject to condition the equation of the circle x square plus y square equal to 4. Okay, who wanted to see this one? Is it okay? Okay, now
Yes,
we
ma'am,
have,
done.
so we'll construct capital F. Let capital F equal to d square plus lambda into x square plus y square minus 4. I can write it in this manner, or I can write x minus 4 whole square plus y minus 5 whole square plus lambda into x square plus y square minus 4. So how we have constructed capital F, I believe you people understood. So where lambda is Lagrange's multiplier. Understood now how we have constructed capital F? Now like the
Yes.
previous sum, here also we have to find out what is fx, we have to find out what is fy and what is f lambda. This we have to find out. Okay. Now putting fx to 0, fy to 0 and f lambda to 0, we will get the stationary point. I'm not going in details, I'm just giving you the point. If you put it fx, fy, f lambda, if you find out and put it to 0, you will get the stationary point as
4,
x equals to
4
4
by
by 1 plus lambda
1 plus lambda,
and
5
y
by 1
equals to
plus lambda.
5 by 1 plus lambda.
5
Now
by
we
1
obtain
plus
the stationary point. So as we have done the previous sum, in the same manner you have to now proceed. Okay. You have to get the points first and you'll solve it. So when I'll upload the material, it is already done. You can go with it. Okay, so time is up. I'm not going with any more problems, but I'm going to upload the study material. So you can go with the solved ones and you can easily solve the problems given to do. Okay. If you have any question from this portion, you can ask me. Whatever taught today, if you have any doubt, if you have anything to ask, you can ask. Is there anything which you want to know? Otherwise, I will end the class. Let me take the attendance.
Thank you, ma'am.
Don't leave, please. Let me take the attendance. Yes, it was recorded.